Okay, this is an attempt to cover this. Okay, we are going to do a binomial table in Excel. This is Excel for Mac. Very brief tutorial, only about 8 minutes long. Okay, let's open a blank workbook. And in this workbook, we're just going to make up a particular example of a binomial. Let's do it for some experiment we're running where, let's say we have 15 trials and we have, let's say a probability of success equal to 35%. So I'm just going to put these into the table, into particular cells of Excel. So I need 15 trials. 0.35 is the probability of success. Then we'll make our table. This will be a very quick way to identify the probability of every possible outcome from our 15 trials. I might have 0 successes in that. I might have, I say, 1 success arises. I might have 2, and so on, all the way up to 15 possible successes in my 15 trials. Let's clean this up a little bit. Make it a little easier to see. And I'll make the headers for my table bold. And now I want to create the binomial distribution. So I'm going to start with the case of 0 successes. So in my function I have the number of successes, the number of trials, the probability of success, and a cumulative true-false statement. If you click on the hyperlink, you see the syntax being described. Number of successes of interest, in that first cell we're interested in a 0 successes, so we enter that. Then I want to know, well, how many trials are there, right? There are 15 trials. Next in the function is the probability of success, so I need to point to the cell that contains 0.35, and then you'll see that if I say false, I will obtain the probability mass function. Click return, and there's the probability associated with 0 successes. Now I need to force Excel to lock that function entry, see cell B3 and B4, I want to fix into place with those dollar signs. Now I can quickly copy and paste that with this drag tool. And now I've built the entire binomial probability distribution for this situation. 15 trials, 35% chance of success. Let's find the mean also, and the variance, and the standard deviation. So here's the expected value of x. Let's remember that that's equal to, right, n times p, the number of trials times the probability of success. So my trials is up here in cell B3, the probability of success in cell B4. And I got a mean of, therefore, 5.25. The variance, according to the textbook definition, is n times p times 1 minus p. So I can insert that function pretty easily. Just point at the cells and write times 1 minus p. And now I have the variance. Let's set everything to the right rather than centered. There we go. And here's the standard deviation of x. So that's, right, the n times p times 1 minus p as a radicand inside a radical sign. So in Excel, the function looks like a hat symbol raised to the 0.5. That would be the exponent of 0.5, right? So that's the square root. So let's replicate the function. Of course, if I wanted to, I could just point at the cell that has the variance score and then raise that to 0.5. But I'm just being completist here, so we're going to clean this up by inserting the exponent. I need parentheses around the entire radicand. Then I go hat 0.5, and now I've got the standard deviation. Oh, I should have written, by the way, SD. I'm not fixing that. But our expected value or mean is this one. The variance, 3.4, and the standard deviation. Just so you guys can see the English language of the functional symbols. So there's my table, all in highlighted form. And that should be enough. No, wait, let me think. Let's also do, well, instead of me stopping the recording, let's also do, just for the heck of it, the cumulative function so you can see how that would look. So that would be finding the probability that x is a certain number of successes or less than that number of successes. So this is a column title, bold that. And this time I'm going to hit the same function, binomial.dist, insert the number of successes of interest, right? And the number of trials, once again, cell B3. Later I'll come back and I'll lock those cells into the function. But now I write true. Now let's do the locking with $3 and $4. That way when I drag and push that function down, it keeps pointing at those cells. So there's the cumulative probabilities. Let's do an example, let's say, where I want to know the probability that I'll have a number of successes of, let's say 8 or less successes. Now you can read that right off the table. Here I'm just kind of writing the note for posterity, that way you can see it. And I look at the table for 8 successes on my cumulative column. That's about 0.9578. So I've been looking at that row for 8 successes. And you see in the cumulative column, that number is really the sum of the probabilities of success from 0 right up through 8 probabilities of success. So that's a nice, quick, easy way to establish a binomial table, either the mass function or the cumulative function. Quite useful. And you can do any case you want. You could switch the trials to, let's say, 132 trials, and then you could say maybe the probability of success is 10%. That would be just reconstruction of one of these, and you should be good to go. You'd be able to figure out probabilities very quickly by just glancing at your finished spreadsheet. So that's it. Let's stop recording.